Hello, ladies and gentlemen. Today we are going over the study guide for quiz 8.1 through 8.2. So this is number 1. Each grid line is 1 centimeter long. Using the picture below, what would be the actual length of the truck? So first we need to find our scale, which is 1 centimeter equals 1 4/10 feet in real life. So we need to set up a proportion to solve this. Our first step is writing down what two things we're comparing. And we are comparing centimeters to feet. Now my scale is 1 centimeter equals 1 4/10 feet. Now to find out how many centimeters the truck is in the picture, I need to count the boxes. So I need to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I would put 12 centimeters on top. Now to solve this, I would first cross multiply. So I have 12 times 1 4/10, which equals 16.8. And then I divide that by the top number, which is 1, and anything divided by 1 is itself. So my answer would be 16.8 feet. A portion of a map with cities A and B is shown. The map uses a scale of 1 inch equals 30 miles. You are making a map with a scale of 4 inch equals 15 miles. How far apart are cities A and B on your map? In order to do this, you're going to need to set up two proportions. The first proportion is going to compare the scale on the map given. I highlighted it above for you. 1 inch equals 30 miles. And you're going to use the map shown, which is 3 inches apart. So we're comparing inches to miles. So we know 1 inch equals 30 miles. And the map shows 3 inches apart. Now to solve this, I would cross multiply. 30 times 3 is 90, and 90 divided by 1 is still 90. So for the first one, they are 90 miles apart, and this map shows them as 3 inches apart. Now we're going to use this information to solve the question asked. How far apart are cities A and B on your map? So now we need to set up another proportion for my map. I underlined above what it says for my map. It says you are making a map with a scale of 4 inches to 15 miles. So we're still using inches to miles. And it's a scale of 4 inches is 15 miles. And they want to know how far away they are apart on a map. So we're trying to find the inches. Now we're going to use our miles that we found of how far apart they are in real life for our map. And I'm going to put that down here, the 90. Now I'm going to cross multiply, which 4 times 90 is 360, and divide by 15 would give me 24 inches. On a scale drawing of a fence, 3 75/100 inches represents 24 feet. What is the actual length of the second fence that is 2 8/10 inches in the drawing? Your first step in solving this would be setting up a proportion, and you want to look at what two things you're comparing. You're comparing inches in the drawing to the feet in actual life of what it represents. On the scale drawing of the fence, it was 3 75/100 inches was representing 24 feet in real life. They want to know what would be the actual length of a second fence that is 2 8/10 inches. So if we put down 2 8/10, we are trying to find out what is the actual measurements. My first step in solving this would be to cross multiply 24 times 2 8/10, and you get 67 2/10. Now you need to take 67 and 2/10 and divide it by 3 and 75/100. And you get 17 and 92/100 feet on the actual measurement. A 12-foot wall measures 2 and 5/10 inches on a scale. In a second drawing, the wall measures 9 inches. What is the actual length of the second wall? When setting up a proportion, you must find the two things you're comparing. In this case, you're comparing inches to feet. On the first wall, 2 and 5/10 inches represents 12 feet. On the second wall, 9 inches represents how many feet, what we're trying to find out. So in order to solve this, you need to cross multiply. 12 times 9 equals 108. Now you need to divide 108 by 2 and 5/10, which will give you 43 and 2/10 feet is the actual length of the second wall. The scale of the rectangle below is 2 inches equals 8 feet. Find the new dimensions of the rectangle, then find the area of the rectangle. Remember, area equals length times width. My first step to solving this would be finding the actual measurements of the rectangle, and I can do this by setting up a proportion. For the first one, we know 2 inches is equal to 8 feet, and the width is 9 inches. So to find the actual feet, I'm going to cross multiply. 8 times 9 is 72. And then when I divide that by 2, I get it's 36 feet. So I'm going to put a 36 up next to the width so I remember that. Then I'm going to find the actual length of the length. I'm going to use the same scale as 2 inches equals 8 feet, but now I'm doing it for 12 inches. So I have 8 times 12 is 96 divided by 2 is 48, and then I'm going to go write that up next to the length. Now to find the area of the rectangle in feet, all I have to do is length times width, which is 48 times 36, which equals 1,728 feet. What is the most specific name for the shape below? Well, referencing our notes given, I can see there's only one pair of parallel sides and 2 sides of equal length. That means the most specific name for this shape would be a trapezoid.